only way that a function can show that. Functions, curvature, like this function goes down and goes up. Why do this sign analysis?
That. So that is the key to our next step, step 3. Step 3 is we need to analyze the curvature of our function. Make sure we really understand what it's doing as it's going down or what it's doing as it's going up. So it's a curvature analysis. And we're going to start with looking at what happens if we do know. And remember the practice question we had as well as the quiz question. What does F look like if its slopes are increasing? Now, typically we just kind of say F prime is positive. That means F is increasing. But what if F prime is increasing? Well, here's an example of some values that are increasing. 0, 1, 2, 3. Now, knowing that F prime are slopes, what would F look like if its slopes progress from 0 to 1 to 2 to 3? Sketch a little piece of F whose slopes go 0, 1, 2, 3. Go ahead, try. What would the function look like if your slopes go from 0 to 1 to 2 to 3? Yeah, good. Good, perfect. Yeah, we see that it's got to have to kind of curve like this. It's got to kind of curve upward. Not a great job so far. All right, cool. 0 slope, 1, 2, 3. These are slopes increasing, creates this type of curve. This isn't the only way slopes could increase. I could add on to this -3, -2, and -1. These values you might be thinking of as decreasing values, -3 to -2 to -1. Oh, they're getting closer to 0, they're decreasing. Nope, that's not the right way to think of it. You are adding 1 from -3 to get to -2. You're adding 1. These values are increasing. So go ahead and add more sketch of F so that we have slopes that are -3, then -2, then -1, then 0, 1, 2, 3. What would it look like if we had these slopes that connect with these slopes, connect with your existing? What would you create? Yeah, good. Good. Now, a lot of people are like, oh, it's got to look like this. But no, that's a positive slope. This is a positive slope, positive slope. What we want is more negative, less negative to a 0. We create this kind of curve. And we call this being concave up or curving upward. And this brings us to step 3. If we know that our first derivative is increasing, we know our function is going to curve upward, be concave up. I'll use CC up to stand for concave up. But what tells you when something is increasing or decreasing? What do you look at? What did we look at on our quiz today? What did you look at on that practice problem? Tell your neighbors. On your quiz today, you guys looked at a second derivative. The second derivative, being positive, will lead you to understanding your first derivative increasing. And if your first derivative is increasing, all of a sudden we understand the curvature of F. You can see that if f prime is decreasing, slopes of 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, we create this type of curve. Big positive, less positive, 0, negative, more negative. So we see that if we are curving downward, we call it concave down. Your slopes will be decreasing. If your slopes are decreasing, your function must be concave down. How are we going to tell when our slopes are decreasing? We will look at our second derivative sign. When you have no concavity, guess what? Your second derivative is going to be 0. You're probably going to be in a situation when f prime is neither increasing nor decreasing. You're going to have no concavity. Now, typically all of our functions curve. They don't have like straight parts to it. So this would be an example of a function whose derivative is simply negative then positive. Let's say it's negative and positive at 3. Okay, f is decreasing to increasing. Now today we won't actually care about this. We're just going to go straight to step 3. Step 3 is you'll have a function. You'll look at its derivative. If you want to analyze the signs of the derivative, great, you get that. But step 3 is going to the second derivative. We'll go to the second derivative so that we can analyze the signs. We'll take it, we'll set it equal to 0. We'll get our nice little number line out. And let's say I have 1, 2, 4, and 5 that I identify. Let's say, just like in step 2, you find the signs by plugging in test points, utilizing multiplicities. It's really the same as what we did, just with another derivative. You find that your signs are positive, negative, positive, negative, positive. Cool? You'll know that f prime will be going up, down, up, down, up. Sure, that's great, but what's important is that you know f is concave up until 1. Now, starting next class, we are going to combine this knowledge with this knowledge to be able to sketch f. Here, you can see f is going down but curving up until 1. Next class, we'll be able to draw that. This is a piece of the graph that is concave up, but we're going down while we're curving up. All of a sudden at 1, our signs change. Now that doesn't mean we have like a max. It's a max of f prime, but a max of f prime is a location where our curvature is going to change. All of a sudden we are still going down, but our curvature just changed from being concave up to concave down. Now we can see we have like a min at 3, and this is probably 1, this is probably 2. But we can see that our function is curving up from 2 to 4. Well, there you go. Our function curves up from 2 to 4. We can see after 3, f is going to be increasing. Well, from 3 to 4, we're curving up, but from 4 to 5, my function must be curving downward. And you'll be able to draw this, sketch this, and see, oh yeah, I'm going up but curving downward. So analyzing curvature is the next step of your becoming a human graphing calculator process. There are interesting points here at 1, at 2, at 4, at 5. These points here where we have zeros of our second derivative, where our second derivative changes sign, these are called points of inflection. POI for short. A point of inflection is where your curvature of your original function changes. So, right here, x equals 1, our curvature changes from being concave up to concave down. We'll be able to identify that as a point of inflection by looking at our second derivative sign analysis, which tells us about your first derivative increasing, decreasing, which tells you about the curvature of your function. Okay? So, step 3, just to sum it up again. You'll start with F. You'll go to F prime. You'll probably analyze your signs of F prime starting next class. For today's class, which is just going to ask you about the curvature, you're going to go straight to the second derivative. You're going to set it equal to 0. You're going to use your sign analysis of your second derivative to tell you about your first derivative increasing and decreasing. And that tells you about how your original function curves. If your second derivative changes sign, this would be a location of a point of inflection. That's when your second derivative changes sign. We don't care if it changes from positive to negative, curving up to curving down, or if it changes from curving down to curving up. They are both points of inflection. We don't have to distinguish them like we do with maxes and mins. It's just those are points of inflection. The second derivative changes sign. Is where our curvature changes. Okay? That's it. You can tell me, you're not going to be a human graphing calculator yet. You're just going to focus on the curvature of your function. Tell me, when is this function curving downward? When is it concave down? Tell me, where does this function have points of inflection? Go. Tell your neighbors, what are you doing? Did you pick up? Were you paying attention? All right, go. You really? I can't even do it in my head. Do it. Let me see.
Yep, got it.
Okay, no. One of them is correct. You didn't have both.
No, I didn't do that. I just did
Okay, so when is your function concave down? When are you curving down? No, I said both. I said both. Now you are going to be my example for what not to do in the future.
What, look this good?
No.
When is it concave down? From 0 to 2. I'm just going to guess.
Okay, that's the key.
Well, right. No, 0 to 2.
Oh, well.
I did not.
I just never reported it to the office.
Okay. Now here's what a lot of students do. They're like, oh, you don't really care about maxes or mins, right? You don't really care about distinguishing. If your second derivative changes sign, you have a point of inflection. A lot of people will just say, hey, these are points of inflection blindly. Okay? Dangerous doing that. Just like critical points are possible, maxes and mins, these, which aren't critical points, your second derivative zeros have no special name to them. They are just possible points of inflection. Okay? So I would not say these are critical points. Critical points are possible maxes and mins. These are just possible points of inflection. I don't want to say they are in fact points of inflection until I do my second derivative sign analysis and confirm that yes, the signs of the second derivative do change at 0 and 2. We got positives, negatives, and positives, which tells me that the first derivative is increasing, decreasing, increasing, which tells me that the original function is curving upward, curving downward, curving upward. So when are we concave down 0 to 2? X equals 0 and x equals 2 are, in fact, both points of inflection. So it does work out, just like sometimes all of our critical points are maxes and mins. Sometimes all of our possible points of inflection are points of inflection. Questions? Concerns? Pretty straightforward. It's like we've done this before. We have. It's just now we're going to the second derivative. All right. Skip the one in the middle, go to the one on the bottom. Try this one out. Do it. Okay. What do you got? This is what happens when you try to do too much in your head. Let's see. Let's see who's going to be right.
So I'm going to guess that. You can't guess.
All right. We find two possible points of inflection. If you just stop after finding when your second derivative equals 0, you're not doing all that you need to do. Just like you don't stop with your first step, you have to go to step 2, you have to do your sign analysis. So we go and we throw down our number line. No, they're not. So hold on. We're not going to change signs at 0 because the multiplicity is 2. To the right and left of 0, our factor will remain positive. So if I'm to the right of 0, I'm positive. That means to the left of 0, I have to be positive. At -3, my multiplicity will change. My multiplicity is 1. Now, words of advice, guys. Many of you do not have your sign analysis label. Now that we have 2 different sign analyses that tell you 2 different things about F, please start labeling it, because next class, it's really nothing new. It's just a combination of step 2 and step 3 at the same time. So we got to make sure you understand, okay, F double prime sign tells about F prime direction, which tells about F's curvature. F prime signs tells us about F going up or going down. Okay, label them. It will help. Okay, X equals -3 is our point of inflection. X equals 0 is not the point of inflection. But what is it if it's not a point of inflection? Well, the easiest way to explain what's going on here, if it's not a point of inflection, what is it? Is by looking at the graph of x to the 4th. If I did the second derivative of x to the fourth, I find that the second derivative is 12x squared. It's got a 0 at 0, and the signs don't change. Which means f is concave up. Then there is a point with no concavity. It is not a point of inflection, though, because the curvature doesn't change. What does that look like? Well, if you look at the graph of x to the fourth, it's very similar to x squared, only it's a little steeper on the outside, and it flattens out more on the inside. Not my best sketch. I probably should have just graphed it using Desmos, but this is kind of what x to the fourth looks like. Well, it flattens out so much that there is a point on x to the fourth where that point doesn't have concavity. It's like linear for a split second. Cool? All right. So that's what's going on here. This is just a point of no concavity, but it's not a point of inflection because your curvature doesn't change. Got it? Great. Well, now let's go to the hard stuff. Let's go to this one. I forgot to change the question. This should be that right there. Please add that in and then answer the question. What do you have to do? All right, take them back. Everybody pay attention to this one on the bottom. I added this guy right here. What am I trying to trick you with doing? I want you to be all in the mindset, oh, I have to take the derivative twice. Well, like, depends. Here, if you're given the first derivative, don't take the derivative twice. You take the derivative one more time, not two more times. This is your second derivative. So make sure you understand what you have. Make sure you pay attention to what you have on your homework. There's going to be some questions when I'll give you f double prime. Just like on your quiz today, there was a question where I gave you a factored f prime. I did all the work for you. Make sure you're prepared for that question. Hopefully you got that question right. And you didn't take derivatives of that crazy factored guy, because that would have been crazy. When are we concave down is x is less than 0 and x is greater than 2. Yep, that's what I just said. Cool. All right. And that's a good segue to the next set of questions that really are the toughest questions and really confuses a lot of students. So I will really try to make it as easy as possible to understand. The graph questions. Now, if you are going to do your homework Sunday night, Monday morning, Monday during second period, who knows? Yeah. Yeah. Do the graphs first, okay? Spend more time on the graphs, making sure you understand it. Because if there's ever a part of this test coming up that students really struggle with, it's the graph problem. All right? All right. I'm just going to challenge you, see if you can get it right. If you do, great. If you don't, it's okay. You're where 90% of the students are every year. This is the graph of f prime. I'm just going to ask you, when is f concave down? See if you can answer that. Ready, set, go. And then I'm going to show you the easy way to get the answers for all of these graph questions when it comes to curvature. But I want you to try it. I kind of want you to fail, just so you realize, oh, this is tricky. There are multiple ways to do this, but I'll show you an easy way to do it. Yeah. All right, so here is what most of us do. Most of us do what we did on our quiz. We plop down -2 and 1 and 3, and we break out negative, positive. But what you realize, guys, hopefully you're realizing this, is that you're like, this is F prime, which tells me about F. It doesn't tell me about F's curve. So this is a good analysis. You'll need to keep this in your brains for the future, but this is not telling me about F curving. It's just telling me about F going up or going down, so I'm sorry. The same thing we did on our quiz today is not what we're going to do moving forward. So here's what I'm going to recommend. And hopefully it'll be easy, because there's going to be other situations, not just graphs of F prime that you're going to be given. Start with the chart. This is important. What do I mean by that? Don't pay attention to this graph over here. Like, ignore it. Pay attention to the question. F concave down. Okay, I'm going to create just a little chart where I know, yeah, F is concave down. That means F slopes are decreasing, F prime is decreasing, and F double prime is negative. Okay, this is my chart for when F is concave down. F is concave down when F prime is going down, or F double prime is negative. Cool? Now that I have this down, I'm going to look at this and say, what is it? It's F prime. Okay, so I could say, okay, if that's the graph of F prime, I'm looking for when F prime is going down. When is F prime going down? Tell your neighbors.
-1.
F prime is going down right here from -1 to 2. Now, here is another way to do this, and it's actually unfortunate because having two ways to do one thing sometimes confuses students. Everybody just wants, like, just tell me what to do. Remember Unit 2 when you had F and I asked you to sketch F prime? What did you do when I gave you F and I asked you to sketch F prime? What did you do? We looked at the slopes. Well, this is F prime. We can look at the slopes of F prime because the slopes of F prime give you F double prime. Oh, these slopes are positive slopes, zero slope, negative slopes, zero slope, positive slope. So actually, there's two ways. You could either look at when F prime is going down, or you can look at when the slopes of F prime are negative, and that will tell you when F is concave down. To be honest, I think it's easier to have the chart down, look at what you have, and then pay attention to which layer you want to pay attention to. This guy. F prime is going down. Now, if I ask you for the points of inflection, the points of inflection are at -1 and 2, because that's when F prime changes direction or F prime slopes change sign. Like maxes and mins of f prime end up being points of inflection for f. Okay, let's see if you got it. Do another one. That's the graph of f prime. I ask you, when is f concave up? Start with the chart. Many of you are looking at this, and you're like, it's concave down. No. Don't look at the graph. Just start with the chart. Write the chart down. Everybody, right now. Write the chart down for when f is concave down. Start with that. F is concave down. Means f prime is doing this. Means f double prime is this. Did you get it right?
I wrote the chart.
Okay, well, what's the answer? No, you're not starting with the chart. F is concave up when f prime is going up when f double prime is positive. Fish, this is what I mean by start with the chart. Draw this. Cool? There are two things you can look at. You can either go back to Unit 2 and understand that this is the slope of f prime, or you could say, all right, this is f prime. When is f prime going up? Answer the question, tell your neighbors, when is f prime going up? When is f double prime positive? Nailed it. Here. You got it, because you looked at the chart. F prime is going up, or the slopes of f prime are positive. No, don't think of it. No.
It's not like that?
No. Just, it's its own thing. We're starting over. It's very important in calculus to sometimes forget everything you've learned in the past. Either it's when the concavity changes. The points of inflection for this one is at x equals 0, because it changes direction or the slopes change sign. Okay? I hear you. Yep. Okay. Some of us are feeling good about ourselves. Some of us still know. Okay. And I give you this question. Like, okay, I got it. And some of you might say, I don't need the chart. I'm better than that. I know what I'm doing. So you either answer this question, never, and that's wrong, or you answer this question, x is less than 0, and that's wrong as well. Because you think you're good, and you think you know what you're doing, and you're not starting with the chart. F is concave down, start with the chart. Yeah. Start with the chart. No.
No,
Nope. You didn't write the chart down, Claudia. Yep. Start with the chart. F concave down means F prime is going down, means F double prime is negative. Okay, great. Now we look at the graph. And I look over here and then, whoa, Mr. Messner is giving me the graph of F double prime. Oh, I will look at this row of the chart. When is F double prime negative? Now tell your neighbors, when is F double prime negative? That's the chart.
It's -1 to 1.
It is -1 to 1.
Is it an arrow down or is it meant to be like concave
No,
down?
this is concave down with an arrow down. That's an arrow down, yes. It's a bad arrow. Okay,
That's what I'm thinking.
why is it -1 to 1? Because here is when F double prime equals 0. Here is where F double prime is positive. It's like the quiz questions we did today. You're given the graph of the second derivative. Your second derivative is positive until -1, negative until 1, positive after that. That means F prime is going up, going down, going up. That means F is concave up, concave down, concave up. X equals -1, X equals 1 are our points of inflection where our curvature changes. Okay. Go back. Go back a page. Go back a page. Yes, you can go back a page. Ready?
No.
Everything I just did, everything you've done, thrown away, gone, gone, gone. Same questions remain, but that's F double prime. You need to know about other stuff. Okay, if this is F double prime, could you answer these questions? What is your graph of F concave up? When is F having points of inflection? We're back here, but I'd change that to F double prime and ask you the same question. The same answers? Nope. Same answers as the previous question? Is it the same graph as the previous?
Yeah.
Oh, no, it's not the exact same graph. It's flipped. It is the same angle, yeah. Good. All right. So we understand that you won't be doing the same thing every time because you're going to be given different things. So here, since this is F double prime, when is F double prime positive? Okay, this is when F double prime equals 0. This is when F double prime is positive. The answer now is -1 to 1. And yeah, it's the same answer as the previous question, but different graph. Okay, we feel good about ourselves now. We go to the last question. Everything's going well. That's the question. So good. Okay, so the first thing you really should be paying attention to is like, what is this graph? What are you giving us? Well, I'm giving you just F. That's the question. That's the thing we got to focus on. What is that? The second thing we should do is create our chart. Okay. F double prime less than 0. Could you fill out a chart from that? Go. Yes, you can.
I'll try.
I believe in you. No. Stay there. Check with the others. What?
Oh, nothing.
Less than 0, fish.
Less than 0. Yeah. Those are what?
No, stop. Less than 0 is not possible. F double prime less than 0, negative. Stop. This is telling me that F double prime is negative. It's not look to the left of 0. All right, F double, what'd you get? Wrong. F double prime negative, F prime decreasing, F concave down. Here's your chart. We start with that. Now, if you didn't draw that, it's going to be hard. Cool. Now we go over here to our graph. What do we have? We have the graph of F. So we go back to the chart and we focus on the third row. Oh, I'm looking at when this graph is concave down. Okay? No. Answer the question. Now they give you a huge hint here. They say, hey, this graph has a point of inflection at 1. So there is a point of inflection at 1. Okay? What's the answer? X is less than 1. F is concave down until the point of inflection, and then it changes to be concave up. I'm looking at F, I'm looking at how it's curving, I'm getting my answer based on the curvature of the graph given to me. This is why, guys, when you're doing your homework, don't do this first page and spend a bunch of time on the first page. This is just step 2 with the second derivative. Okay? You go to the back. You do these questions on the last 2 pages first, because those are the questions that people mess up on the most. Okay?
Why doesn't it work? Look at when the slopes are negative.
That's when F slopes are negative. That's when F is decreasing. You need when the slopes are decreasing. So look, slopes are 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 2, negative 1, 0, 1, 2, 3, 4. Yeah, it's the same deal.
Well, I mean, F prime increases there. So that means 1's the inflection point?
Yeah.
Is this also an inflection point?
Yeah.
Waiting for the outro.
That was it.
That's it?
That's it. We're done.
Looking up anything? Good weekend or nothing like that? Very disappointing.
Hey, guys, have a great weekend. We'll see you on Monday.